Supervised learning is a key technique used in artificial intelligence today, providing a set of algorithms that enable the development of AI models we use daily. Each time our phones identify objects in images or videos, a supervised learning AI model is likely at work. Whenever your streaming app suggests new content, it's likely powered by an AI model trained on your listening history and content preferences using supervised learning. Health apps that estimate biological age based on vitals often rely on an AI model, again trained using supervised learning techniques, to carry out what we call regression, where we determine a value using multiple other values. In this case, we calculate the biological age using multiple vital statistics, including heart rate, oxygen levels, and blood pressure. Supervised learning is a machine learning approach that includes algorithms to train an AI model to classify content in images, videos, or text. Supervised learning algorithms can also develop AI models to predict a value from related inputs, like we have seen in the health app example. To accomplish this, supervised learning uses labeled datasets in the form of structured tables or media like images, video, sound, or text. Labeled datasets clearly mark both the input and the data we want to predict, which is normally called the output data. Supervised learning algorithms train AI models on large labeled datasets to map input patterns to specific outputs by learning the data patterns between them. With the learnt data patterns, the AI model can then predict outputs from new unseen input data. In the music app example, supervised learning uses labeled input, like listening history and liked tracks and liked albums. The data you are trying to predict, which in this case is the favorite artist, needs to be labeled as the output data. The supervised learning algorithm then processes millions of these types of labeled datasets to learn patterns linking inputs to outputs. All these learned patterns are then stored in an AI model, enabling the AI model to predict output data from unseen input data. For example, we can use a new music listener's history and liked songs and albums to predict artists they'll likely enjoy. In the photo example, supervised learning uses labeled images to train AI models to identify objects in other images or videos. The AI model learns patterns in each image, first by having a numeric representation of it, and then linking the data patterns to the labels, which are object names. When shown a new image, it's again converted into a numeric representation, then processed by the AI model and classified into known objects. The AI model doesn't see images, it recognizes number patterns from the training data to identify objects. For example, it can recognize a cat because it was trained on hundreds of labeled numeric representations of cat images. There are two types of supervised learning. Classification algorithms train AI to recognize patterns as labeled outputs. In photo recognition, pixel and color data act as inputs. Labels assigned during training are outputs, allowing AI to name objects from visual patterns. Regression algorithms in supervised learning predict outputs from related inputs, ideal for building AI models that forecast values. Just like our earlier example, AI uses labeled inputs, heart rate, oxygen, blood pressure, to predict biological age. Each type, classification or regression, offers various supervised learning algorithms, each with unique data handling and model building methods. Let's explore more examples, starting with classification, using labeled email data to train an AI model to detect spam emails. Each email in the dataset of hundreds of emails serves as input data, and the assigned label of spam or not spam for each email is the output data. When presented with a new email, the AI model classifies it as either spam or not spam, analyzing the email's body, subject, sender, keywords, and formatting to reach a conclusive classification. The same classification approach applies to customer sentiment analysis, using customer reviews as input and the labeled sentiment as output. The AI model predicts sentiment, positive, neutral, or negative, for new customer reviews, thanks to training on hundreds of human-labeled examples. Next, let's look at a regression example, training an AI model for financial forecasting using monthly ad spend, website visits, and date data. Given monthly ad spend and website visits, the AI model predicts that month's revenue. Now that we understand what supervised learning is and its use cases, let's examine a typical workflow. You first need data scientists who understand data requirements in the context of training an AI model using supervised learning techniques. Data scientists must then collect and label training data to define inputs and outputs, also sometimes known as features and targets. The team must optimize the data by removing data bias and outliers that could skew results, like, for example, customer sales during a postal strike when we are trying to create an AI model for financial forecasting. We also need to split the data, some for training, the rest for validation and testing the model. A process known as cross-validation, where we set aside training data for later to test accuracy of the AI model and prevent overfitting. Overfitting happens when an AI model fits training data too closely, but struggles to predict the expected results when working with unseen data as the input. Next, we select a machine learning platform to build and train the AI model. We then choose a supervised algorithm and decide on either a classification or regression type algorithm that suits our needs. Next, we review the algorithm's parameters to fine-tune the AI model's accuracy. Once the AI model is built, we test it using unseen validation and test data. We evaluate the AI model's performance by comparing predicted results to actual values in the test data. If accuracy is poor, we revisit the previous training steps, tweaking or switching methods as needed. Creating the perfect AI model isn't always smooth. Challenges inevitably arise. Firstly, you need a skilled data scientist who can apply supervised learning effectively. These are rare and expensive individuals. Secondly, supervised learning requires heavy manual effort to collect and label training data, time-consuming and prone to errors. Data optimization is also prone to human error and bias, like accidentally overloading with January data when New Year's celebration songs skew new artist recommendations in our old music app AI model scenario. Securing enough human-labeled data for training, validation, and testing is also time-consuming and costly. Even with perfect data, trial and error with platforms, algorithms, and parameters still costs time and money when trying to build an accurate AI model. Even during performance evaluation and revising and tweaking our training strategy, we need highly trained data scientists who know what to do when our AI model's prediction results are poor. We need a strategy for evaluation and testing, as well as a plan for revisiting the workflow when we need to adjust our approach. If supervised learning feels too demanding, other algorithms may ease some of the challenges. Unsupervised learning needs less human input. Algorithms find patterns in unlabeled data without guidance. Semi-supervised learning blends both approaches, using some labeled data to guide pattern finding in unlabeled sets. Reinforcement learning takes a different route. No labeled data, just trial, error, and rewards instead of pattern analysis. The good news is that there are many options to make your AI strategy work. This has been Rag Diamond, and thanks for watching this video on What is Supervised Learning, a video which is part of my AI Basics series. Please remember to like and subscribe. Your support will be greatly appreciated.